Well, hello everyone. It's Martin Lush here from NSF Health Sciences. It's great to see you all dialing in again. I think we've got 140 people dialing in from 11 different countries, as far east as Singapore and China, as far west as the east coast of the United States. So whatever time of day, evening or night it is, very warm welcome to you all. My promise to you in this short, sharp session, ladies and gentlemen, is to share best-in-class practices in relation to prevention of human error. For this short session, I want to really focus on some specifics, namely the psychology of human error. That is why, really committed, intelligent, motivated people make mistakes. Also want to provide some access, free resources to you. There's lots of free resources available to you at the end of this session. And really what I also want to do, as with all of these webinars, is to inspire you to go away and learn more about this fascinating subject. For those of you who are regulars to our program of webinars, this is the fourth of our free webinar programs. This is your program. We, at the beginning of the year, asked you what is it you would like us to talk about to provide really useful content. These were the lists. We're in April, and it's on human error prevention. But as you can see, pretty wide range of interests, all culminating. I'm going to be fascinated by the one at the end of the year, Conquering the Chaos, How to Thrive in an Uncertain World. That'll be great when I figure out what I'm going to say to that. But for those of you new to the sessions, these are short, sharp, just 30 minutes long. All are recorded, so if you haven't been participating in the program so far, you can go to our website and download all the recordings, not just of this year's webinars, but also the preceding couple of years as well. I will answer all of your questions. A lot of you send questions during the session that come through on the chat feature. Unfortunately, I can't multitask, as we'll cover later. So please send me your questions either by email or as you send them to me during the session, and I do get back to everybody. I do set up calls to answer your questions in full. Really, please give feedback for these sessions. That's the only way we can improve and get better is through your feedback and recommendations. And also I'd encourage you to follow me on LinkedIn. I do a lot of posts on not just error prevention, but quality culture as well as a few technical subjects. So if you follow me on LinkedIn, you get access to those posts as and when they are published. I'm Martin Lush. I'm VP of NSF Health Sciences. I've been in the industry for a pretty long time, and I've always been fascinated by the why. That is why really committed. Often, in fact, your biggest mistakes are made by some of your best people. And I've really been a frustrated psychologist, I think, throughout my career in trying to understand, what goes on between people's ears and why they do make mistakes. So I've really been a student of error prevention, if you like, and that's taken me to talk to subject matter experts in aviation and nuclear and the academic field as well as those in the automobiles. So a lot of people, a lot of sectors have really invested a huge amount of time in trying to understand why people make mistakes, and not just understand, but apply that knowledge to prevent those mistakes from happening again. So, it's really quite interesting why mistakes are made. Perfectly sane, rational people actually doing, in hindsight, that is after the event, some crazy things. This is one of my favorites. You will note, actually, this observation was made by my wife. She said they're all men. I think that's probably a subject of a second webinar or another webinar on the subject. But I think if you to ask these, you look at this picture, and for those of us, hopefully all of us, who have a safety conscious alarm inbuilt, you'd look at this and say, well, that's a disaster waiting to happen. But I think if you were to stop these guys and ask them why on earth are they taking these risks, these would probably be some, if not all, of the responses that you'd get back. Why are you taking those risks? Well, Martin, we just do as we're told. We're focused on getting the job done. And by the way, our rewards depend on it. The way that we're measured depends on us getting the job done no matter what. or, we simply don't have the right equipment, and, we've been doing it for years and nothing's happened. And by the way, leadership and management know about it. The point I'm making here, ladies and gentlemen, is that most people, virtually everyone that is sane and rational, will always do the best they can with what they have available. Nobody gets out of bed in the morning and intentionally messes up. There's always a reason behind it. And the purpose of this webinar is to give you far more knowledge and understanding, so the next time you embark on a prevention program or on an investigation into a deviation incident, at least you're doing it from a far better, a far more informed background and basis. Those pictures are funny. This one is not funny. I come from a hospital background, so this one resonated with me because I have a real passion for our health service in the UK, and this was an example a few years ago, in fact. For those of you who are not familiar with this piece of equipment or its type, this is a pump that is often used for infusion of anti-cancer drugs, for example, over a prolonged period of time. So this particular pump was used to infuse chemotherapeutic agents. The correct flow rate was 1.5 milliliters an hour. The rate actually set by the nurse in question was 15 milliliters an hour. So you can imagine the consequences of infusing a pretty toxic medicine into a patient rapidly in the way there was pretty dramatic. The patient didn't die. However, it was reported as human error. The nurse was punished, in fact, fired for it. But in terms of what actually did happen, the investigation that took place afterwards actually exposed this error chain. And we'll talk a little more later about error chains, because there is no such thing as a single root cause. That's a really important message to take away. If you look for one root cause, you typically stick at the one you find first, and that typically is people. So people often get blamed for what is a system error. So, the intended flow rate was 1.5 milliliters an hour. The nurse accidentally entered an extra decimal point. I think we've all done that. She, in removing that decimal point, hit the backspace. I think we would all do that. But unfortunately, in hitting the backspace, the way that system was configured on that particular piece of equipment actually removed both, not just one, but both decimal points. So inevitably, the flow rate was inaccurate. Now, you're all probably sat there and saying, yes, why didn't the nurse spot the error, Martin? Well, we all know that the brain typically sees what it is used to seeing. I was involved in a packaging-related product recall many years ago. A very obvious recall on the labeling that had been reviewed and approved by 27 separate people. And that's not unusual, because the brain gets into a pattern of thinking and it typically sees what it is used to seeing. But if any of you are, as my background in the health service, I know how busy hospital wards are, I know how pressurized they are, and I know how many distractions there are in a typically very busy working environment. So, that probably contributed to this mistake. Now, was it the nurse's fault? Well, you could argue it was human error and she should have detected it. I would argue that it was the system that led to that mistake. And I would also argue that blaming it on the individual and not fixing the system means that risk is still there for the next occasion. I think we've all had experience of human error, whether it's just putting fruit juice on your cereal rather than milk, or, as we were explaining earlier, for those of you that dialed in, leaving your wallet at an airport in India. Now, what I'd like to do is to give you a flavor of the top 10 best industry practices in relation to error reduction. Now, 15, 18 years ago, I designed our course program on error prevention, and I spent a huge amount of time with subject matter experts in fields or in industry sectors that have worked tirelessly to reduce human error, whether it be in the military, automobiles, aviation in particular, the nuclear, or indeed the oil or microelectronics industry. So what I found was that they all did 10 things exceptionally well. They did them differently, but nonetheless they did them exceptionally well. So these are the 10 best practices for error prevention, because I'm a firm believer in not reinventing the wheel, but actually stealing with pride. So if there are examples of best-in-class practices that people have applied and they work, all we have to do in the pharmaceutical industry is just take them, apply them, not overcomplicate them because they've been proven to work, but let's not reinvent the wheel. So here are the top 10 best industry practices for error prevention. Number one, all of these companies, these sectors, had a positive attitude to errors. In other words, they had what I call an open loop culture. So these are cultures where problems are seen as good, they're openly discussed, they're shared, and people learn from them. They all had a blame-free speak-up culture. Now, 1 and 2 are absolutely vital because without 1 and 2, you go nowhere in terms of error prevention. Number 3, which is what we're going to major on today, is all of these companies have an excellent understanding of the psychology of human error. What that really means is that they design with the brain in mind. They design their SOPs, they design their equipment, they design their shift patterns. Everything they do is designed with error prevention in mind. Number 4, they think error chain, not root cause. I always emphasize this: ban the term root cause from your vocabulary, because as soon as you look for one thing, you typically stick at that first thing, which is the people, the nurse who made that mistake, rather than looking at the contributing factors that led to that. In other words, the system errors. You just stick at the surface. Now, by thinking error chain, you actually dig beneath the surface and you look at the systems rather than the person. Number 5, they focus not just on active failures, but also on the latent or system failures. And the best-in-class companies, when they trend their deviation incidents, they only have 2 categories, which is those relating to active, in other words, where people have made the mistake, and those mistakes that are due to the hidden, in other words, latent problems normally buried within the systems. And Pareto was right. The 80-20 rule applies here. 20% probably attributed to the people. In fact, a little less in my experience, but certainly 80-90% of human error is down to systems and practices rather than the people using them. Number 6 in the best-in-class practices is that these organizations don't train, they educate. I think we all know the difference between the two. You educate your children, you train your pets, hopefully not the other way around. Number 7, they all have robust system safeguards to capture, contain, and remove errors before they get to the end user. Number 8, they all have really, really sensitive detection systems, one of which is the deviation and kappa system, another of which is the audit and self-inspection system. The most important error detection system, though, is really vigilant, high-quality supervisors on the shop floor. Now, the best-in-class companies, ladies and gentlemen, have a PACA focused. Those companies out there who have a deviation and kappa system will always be firefighting. Those of you who have a deviation and PACA system will always be successful because your focus is on prevention, not correction. So that's really, really important. Number 9 we're going to talk about as we go through. Number 9, best-in-class practice, all of these companies are obsessed with simplification. They take simplification to a PhD level. And number 10, they really invest heavily in error proofing and user-centered design. So if we are serious as an industry about error prevention, and many companies are getting serious about error prevention, because if we don't, if errors continue, risk increases, cost increases, and everybody loses. Now, I'm going to cover just two here, ladies and gentlemen. I'm going to really focus on the psychology of human error, that is the brain. I'm also going to touch on simplification, because simplification is survival in our industry now. The best companies will be those who simplify. But the point of this picture is that those two are just two parts of the jigsaw puzzle. Without the positive attitude to errors, without the blame-free, none of the others really work. They don't happen. But we need to do all of these exceptionally well, and when we do, errors actually reduce. So let's just focus on the psychology of human error. Now, there's an awful lot on this slide, and I'm just going to take my time to talk you through each of these elements, because this is really, really important, because once you understand our own limitations as human beings, you can start to use that knowledge to design better SOPs, design better workplaces, design better shift patterns. Now, the brain has really remained the same since our ancestors roamed the plains of whether it be Africa, North America, Northern Europe. And it is frankly not designed for all of the modern day distractions that modern day life throws at it. Starting there with cognitive overload. Right at the front of the brain is the area called the prefrontal cortex. It's often referred to as the executive brain. And this is the part of the brain that actually you're all using now, hopefully, which is, this is where the conscious, really focused thinking takes place. But it has its limitations. It can only remember 7 facts plus or minus 2. We keep these webinars to 30 minutes because that is actually right at the outer limits of concentration for many of you. And for many of you, translating what I am saying into your own language, your cognitive overload is even greater. So the part of the brain where logical analysis, focused thinking, concentrated thought takes place is very, very quickly overloaded. That's why virtually all of the SOPs that I see in the industry are impossible to read. They are impossible to understand simply because they leave people overloaded. So we need to remember that the brain that looks at making tough decisions and the logical analysis components is very, very quickly swamped. The impact of stress and fatigue is also profound. I think we all live our lives with an element of stress and fatigue. The more stressed we are, the more tired or fatigued we are, the greater the risk of errors and mistakes. So one company I know who work 24/7, just the same as many of you do, their plants were sort of 90% utilized, so that meant there was a night shift, and they very quickly recognized that mistakes were increasing in the night shift, not surprisingly because of physiological stress as well as physical fatigue. And what they did was to remove all their complex tasks and have that night shift just do the simple things like preparing equipment, preparing autoclave loads, rather than complex activities that require a lot of thinking. So impact of stress and fatigue can be really profound. So, never make tough decisions late in the day, late in the week, when you're tired and stressed, because they inevitably will be wrong. Sleep disruption is always for those of you that have experienced jet lag, you know exactly what that means. For those of you who've got young children and experience sleepless nights, you would know exactly what that feeling of thinking in fog is, how I used to describe it. And sleep disruption, whether it be through shift patterns at work or activities outside work, has a profound effect on errors and mistakes. Now, no surprises there really. This one might surprise you. The brain cannot multitask. My daughter argues with me. She is 21 and she used to do her homework listening to music, texting her friends, and at the same time as studying. And I used to say to you, you can't do that. Now, what I mean by multitasking is concentrated thinking where you are really focused on a particular task. You can only do that on one task. So if your processes and practices require different things to be done at the same time, you are setting yourselves up to fail. And just reflect on how many of your SOPs, how many of your batch manufacturing records actually require people to multitask. As soon as you, for many of you, if you're working on a Word document that requires a lot of thinking, and suddenly somebody emails you or they phone you up and you respond to that request, it takes you 10 to 15 minutes to really focus back on the task in hand. So multitasking is a big cause of errors and mistakes, as indeed is poor diet, groupthink. When the group dominates the thinking, can also contribute to errors and mistakes, as indeed the power of habit. Most of the decisions and actions we take, well, most I would say about 40 to 50% are habitual. In other words, we act without thinking. And once we established a habit, it is impossible to break. The habit can only be replaced by one that is stronger. So whatever you do, ladies and gentlemen, don't change anything in an SOP or in a practice weeks or months before an FDA inspection, because when operators are asked questions relating to the new SOP that they haven't had time to practice, often, well, in conditions under stress, they will only remember the old SOP. So habits, and this is a subject of another webinar, are really, really difficult where they're impossible to break, they can only be replaced. And then obviously bias is a big part to play in our thinking as well. So, when you're doing your next error investigation, ask questions. Look, was this person multitasking? Was this person distracted? Was this person fatigued? Have we got the shift patterns designed incorrectly? Do we have enough people on the production line? Is the calculation too complex to the extent that it's leading to overload, etc., etc.? But it's really worth just reflecting on this overload component, because I think one thing that the pharmaceutical industry is really, really good at is overcomplicating. I did a webinar a few months ago on simplification. There's a few references at the end on the art and science of simplification, because this is really going to be key for our future in the industry. How many of you have seen screens like this? How many of you have been shopping in supermarkets like this? Do you find it particularly relaxing? I certainly don't. And it's interesting, the discount supermarkets in Europe, certainly in the UK, the likes of Aldi's and Lidl's, where you don't have 15 choices of olive oil, you have 3. Where you don't have 10 choices of tuna, you have 3. And when they surveyed customers who now are outperforming, these stores are outperforming the larger stores, when they surveyed them to ask why do they shop there, sure, discounts were an issue, were a key selling point, but the number 2 was actually it's simpler. There's less overload, and it's an easier and more pleasant shopping experience. Now, the key thing is using this knowledge of how we think, and I've really just given you the flavors of, the highlights of how the brain thinks and what can contribute to human error, simply because the brain can't deal with the levels of complexity or the levels of distraction or the levels of fatigue that so many people are exposed to. The key thing is, how do you use this knowledge to transform large and complex documents to documents that are easy to use? And this is an example, ladies and gentlemen, of a brain-friendly document. Gone are the blocks of text. We have the use of color to make information stand out. We have the use of photographs for particularly critical items of equipment. We have alignment of signatures. So this is something that is more easy to use from a brain perspective. So ask yourself the question, how does that compare with the SOPs that your operators are being expected to use under really, really difficult conditions with multiple distractions in the environment? Now, people say to me, Martin, what is can you give me some examples of a brain-friendly document? Well, this is one of them. Much depends on the level of information that you decide to put in, and that depends on the level of investment in educating people. The better educated your workforce, the less information you have to put into the SOP. But I also say to them, look, this is one example of a brain-friendly document, but for most of us, we're all surrounded by brain-friendly documents at home. If you want an example of a really good brain-friendly instructional document, just go to a recipe book. You've got pictures, you've got the ingredients, you've got the key steps, equipment that you need, it's all in logical order, and even people like me can follow most, I wouldn't say all, but most recipe books. So one of the key objectives you must have in preventing errors is to prevent overload. Now, prevention is through good design of your process, your equipment, your workplace, documentation. So keeping it simple prevents overload. And then on the right-hand side, to standardize, to simplify, to reduce people-process interactions. Whenever we simplify, we make it easier for a habit to be created. We also need to remove distractions, reduce options available to people, and think more creatively about how do we prevent overload, because less is more. Just remember that, less is more. And if you go into a good GMP environment, one of the benefits of a good GMP environment is less overload. Everything is where it should be, rather than a chaotic environment which leads to overload. So think very carefully about what the brain's capabilities are and design your processes accordingly. Number 9, I just want to spend time on, ladies and gentlemen, because it does sit alongside what I've just discussed, because in order to prevent overload, you need to simplify. Simplification is survival, remember that. And we've all got to adopt a philosophy of less is more. We wrote a journal article, a whole journal in fact, dedicated to simplification. So if you want a copy of that, just drop me a line and I'll send it to you. We introduced a term called brutal thinking, which is where you really think carefully about what is essential, what is not, and then you slim, trim, and cut. You get rid of anything that adds no real value to the core purpose of what you're trying to achieve. None of that is possible without really good foundations in risk management, because when you do simplify, there is an element of risk, and you need to manage that risk, and you can only do that if you're really confident with principles of risk management, for example, in ICH Q9. And one thing that's really, really key, ladies and gentlemen, just to stop complexity being added, deviation and kappa systems fail when they add complexity. In other words, when people make mistakes, the responses or the corrective actions usually are either retrain, add more information to the SOP, add more checks and signatures to the batch record, add more, add more, add more. In other words, add complexity that then leads to even more errors and mistakes happening. So to prevent complexity from being added, you've got to control your deviation and kappa systems, as well as your audit and self-inspection systems and change management, so that they only simplify rather than complicate. And the focal point for our attention is always the user, what the user needs, what the user requires, and that means engaging the user whenever we're trying to simplify. Now, I'm not naive enough to believe that simplification is possible in everything. We live in a complex world. We all have complex supply chains. Maybe this is your supply chain. But there is a level of complexity that is beyond our control. But I'd say a lot of complexity is added because we try and be too smart, too sophisticated in adding things that actually are not required. And this is just to give you a flavour of the return on investment. Simplification is really hard work, but as you can see here, we helped one client who had just over 3,500 SOPs, average number of pages 26. 57% of their deviation incidents were due to errors related to SOP non-compliance. We took 100 of their most at-risk SOPs. We ran a 2-day simplification workshop, and the product of all of the hard work generated in that workshop was that the average number of pages were reduced to 11, 78% reduction in word count. In other words, we replaced words with pictures and schematics and diagrams. And the return on investment was almost 90% reduction in deviations, almost $800,000 saved, and lots of happy people because of less stress, less cognitive overload. So the point here is simplification is survival, but simplification is hard work, but you don't have a choice. If you want the benefits, you've got to put in that hard work. But please take a look at the journal article because it tells you how to do that. Change control. Often that level of complexity only results in people navigating their way around it, so you no longer have control over change. Just one last point on complexity, ladies and gentlemen. Often the time that most complexity is added is after a really poor or bad regulatory inspection, when the pendulum swings from having not doing enough, which is why you get the criticism, that swings all the way across to you ending up doing too much, often due to really bad consultants who think more is better rather than less is more. And the job of leadership is to ensure that you hit the sweet spot. In other words, the levels of complexity are workable and they are always with the user in mind. So in bringing this to a close, ladies and gentlemen, remember, error prevention is possible. We know it's possible. I focus for this session on the psychology of human error and simplification. Those two go hand in hand. But you've got to excel at doing them all. And if you want more information, please just let us know. We run a fantastic course on human error prevention where we talk about each of these in more details. And here is your access to free information. There's webinars, there's white papers on how to change workplace behaviors, how to reduce human error. So just follow those links and you'll be taken straight to those white papers and more. There'll be more on simplification there as well. And please follow me on LinkedIn. I run a LinkedIn Human Error Prevention group, so please join that if you need more. So all of these resources are there for your benefit, so please make use of them. So that's it for April, ladies and gentlemen. May continues with effective self-inspections, best industry practices with Mike Halliday, my colleague. And it just leaves me to say a big thank you for listening in. And as always, lots of questions have been coming through. I will be in contact with you and I will personally answer all of the questions, give you whatever free resources that you need. So thank you very much for contributing. Follow me on LinkedIn, and if you have any more questions, please just contact me and I will get back to you. So see you all in May then. Thank you very much indeed.